What if I told you that right now, far above us, a visitor from another star is racing through our solar system? It's called 3I Atlas, first spotted by a telescope in Chile in July 2025. To scientists, it looks like a comet, but some wonder if it's something else, something designed, something watching. Tonight, we'll explore what would really happen if 3I Atlas isn't just ice and dust, but alien technology hiding in plain sight. Before we begin, make sure to like and subscribe if you love late-night cosmic what-ifs. And tell me in the comments, where in the world are you listening from, and what time is it right now? Hello, dear listener. Tonight, I'd like to invite you to a different kind of story. Not the kind with kings or monsters or fairy tale endings, but a quieter story. One that drifts in on the edge of awareness. The kind of story that belongs not to people, but to the cosmos itself. Picture yourself lying back, shoulders softened, eyes heavy, letting the day dissolve. The room is dim, the world is hushed, and the night sky stretches above like an ancient dome. Stars scatter themselves across the dark canvas, each one steady, each one older than memory. But among those steady lights, every so often, a traveler passes through, a streak, a glimmer, something not fixed but moving. We call them comets. Yet tonight's whisper isn't about just any comet. It's about one with a name as cryptic as a password. 3I Atlas. Official, clinical, almost too sharp to carry wonder. But names are deceiving. Behind those numbers and letters is something that carries an older resonance, one we don't yet understand. And the question that lingers, perhaps too quietly for daylight, but perfect for the soft hours before sleep, is this: what if it isn't just a comet at all? It begins as a dot. That's all. Imagine staring at a screen in some distant observatory, your coffee cooling beside you, your eyes tired from a night of waiting. And then, suddenly, there it is, a small, almost imperceptible dot of light inching across the frame. No fanfare, no cosmic trumpet, just a silent guest arriving from elsewhere. Astronomers know how to recognize such dots. Most are local. Asteroids, fragments, ordinary members of our solar system's bustling family. But every now and then, something moves differently. Its path isn't curved by our sun in the way that familiar objects are. It comes in at an angle too sharp, too strange, too free. And so the whispers begin. This one is not from here. Already there's a story in that. A visitor from beyond, slipping into our skies like a stranger at the edge of a campfire. Do you feel that tug in your chest? That hush? It's the same feeling our ancestors must have had when they saw comets as omens. Portents of war, signs of death, symbols of gods tearing through the heavens. To us, it's data, graphs, spectrographs, wavelengths. Yet beneath all that, we feel the same quiet thrill. Something has crossed a distance we can barely imagine to be seen by our fragile eyes. And what distance it is. Interstellar. The word itself hums with immensity. Not just from another planet, not just from another star, from another system entirely. A realm where light has to march for centuries before reaching us. Where suns rise and fall, unseen, with their own stories and histories. 3I Atlas is a messenger from such a place. Now, whether you believe in messengers or not, that's your choice. Some people lean toward wonder, imagining alien hands guiding its path. Others lean toward caution, saying, no, it's simply ice and rock, nothing more. But whichever side you rest on, the truth is that this little speck in the night has already become something larger than itself. It has stirred imagination. It has made us whisper again. And isn't that the beginning of every great story? Tonight, we're not just going to trace its orbit or list its chemical composition. We'll do that, yes, but gently, in time. What matters first is this moment, this pause before sleep, when we admit that we don't yet know. That's a rare gift in science, and rarer still in life, to not know and to let that unknowing soothe instead of frighten. Because what if it is something else? What if beneath its frozen surface lies not just chemistry, but design? A casing, a signal, a technology so advanced it disguises itself as ordinary ice until we learn to look deeper? Or what if it's only ice? What if the wonder isn't in aliens or machines, but in the fact that something born under a different sun now brushes ours? Both are extraordinary in their own ways. So tonight, let's lean into the whisper. Let's let curiosity take the wheel for a while. Imagine the comet, 3I Atlas, turning slowly in the dark, its surface catching sunlight faintly, like frost on ancient glass. Imagine it carrying not just dust and ice, but the fingerprints of another system, another history, another elsewhere. As you breathe, slow and even, let that image settle. A quiet traveler, drifting across the vastness, unnoticed by most, yet carrying within it the possibility that we are not alone. Not alone in space, not alone in time, not alone in wondering. That's the whisper before sleep, a whisper that says, maybe. On July 1st, 2025, the sky over Chile was clear. High above the desert, the air thinned into silence, and one of Earth's great eyes opened, one of those telescopes that see not just farther, but deeper than human sight ever could. Inside its dome, a camera took patient exposures of the heavens, frame by frame, like breaths of light stretched across glass. And in one of those frames, in a corner almost overlooked, there appeared a dot. That's all it was, just a dot. If you had glanced at the screen, you might have missed it. You might have thought it was a smudge or a stray pixel, the kind of nothingness that fills our skies. But astronomers are trained not to look away too quickly. They know the difference between static and motion, between a mistake and a message. Over the next few nights, the dot moved, slowly, softly, as though it had all the time in the world. Each new image traced its journey across the digital sky. Not fast, not dramatic, but steady. And already that told them something. It wasn't ours. Objects that belong to our solar system behave like family. They orbit, they circle, they fall into the same patterns we know by heart. Asteroids loop, planets glide, comets approach, flare and recede. But this dot, this tiny wanderer, its motion didn't match the familiar dance. It carried with it a strange trajectory, one written in a language foreign to the solar system's rhythm. It came not from within, but from beyond. Pause here for a moment and picture that. A single pixel on a monitor, nothing more than light captured by glass and mirror, already telling us a truth bigger than any one human life. Something has entered our neighborhood from elsewhere. Not from Mars, not from Jupiter, not even from the Oort cloud, that distant halo of icy fragments that surrounds our system. No, this dot had crossed interstellar space. It came from the realm between stars. How far? We can't say exactly. Maybe from a system where twin suns rise together, casting shadows in two directions. Maybe from the outskirts of a galaxy spiral where stars are sparse and cold. Maybe from a place where no life ever stirred, where silence is the only companion. Or maybe it came from a place where someone, something, sent it. The telescope operators in Chile didn't leap to that conclusion, of course. Scientists are careful, cautious. They logged its coordinates. They compared its path. They shared data with colleagues in other observatories. Slowly, confirmation spread. A new interstellar object, only the third one humanity has ever recorded. The first was in 2017, ʻOumuamua, that long, shard-like visitor that tumbled oddly and left us with more questions than answers. The second was in 2019, Borisov, more like a normal comet, a ball of dust and ice that felt familiar even though it wasn't born here. And now this, 3I Atlas, the third interstellar. 3 in less than a decade after millennia of seeing none. A pattern begins to emerge, doesn't it? Almost as if the sky is whispering, you are not as alone as you thought. The cosmos does not keep its borders sealed. Sometimes its travelers wander into your field of view. And yet, for all the drama we attach to it, 3i Atlas didn't arrive with fire or thunder. No bright streak across the sky, no trail of sparks. To most of the world, it was invisible, unnoticeable. A single pixel in a dataset. Its importance lay not in what it looked like, but in what it implied. Think about that. In a world of breaking news and blinding headlines, the most extraordinary discovery came disguised as nothing at all. Just a speck. A faint light that could have been dismissed, if not for the patience of a few humans who refused to look away. And maybe that's the lesson here. That sometimes the universe doesn't announce itself with spectacle. Sometimes it whispers. Sometimes it hides its messengers in plain sight, trusting that those who are watching closely will notice. What questions does such a speck carry? Could it hold within it the chemistry of a different sky, molecules shaped by a sun we've never seen? Could it be a frozen archive of time older than Earth's mountains? Or could it be something made, a probe, a vessel, disguised to look like every other comet we've ever known, passing through quietly, recording, listening? We don't know. And that's the beauty of it. Because even before the first analysis, even before the first spectra, the first measurements of its tail and coma, the first debates in journals, this little dot had already done something remarkable. It had made us ask. It had cracked open, however briefly, the door between certainty and wonder. So, as you drift, imagine that dot moving slowly, softly across a telescope's gaze, not loud, not grand, but undeniable, a stranger at the edge of our light. And imagine, just for a moment, that it might be looking back. There is a quiet significance in the number 3. Ancient cultures marked it as sacred, a balance point between chaos and order. In stories, it's the third trial that reveals truth, the third visitor who brings change, the third signal that can no longer be ignored. And now, in the vast record of our sky, humanity has logged its third interstellar object. First came ʻOumuamua in 2017. Its name means scout or messenger in Hawaiian, and perhaps never has a name been so perfectly chosen. It wasn't just unusual. It was bizarre, long and thin, tumbling end over end, accelerating slightly as if pushed by some invisible hand. It left behind no easy explanations. Was it rock, ice, or, as some dared to ask, a fragment of alien technology? Before we could decide, it was gone. Then came Borisov in 2019. Unlike ʻOumuamua, Borisov looked the way we expect comets to look, an icy nucleus shedding dust and gas in a long, luminous tail. It behaved in ways we could chart and predict, and for many, that was a comfort. It was alien only in origin, not in nature. A reminder that the universe recycles its ingredients, that ice and dust swirl into familiar shapes even under foreign stars. And now, 3i Atlas, the third interstellar. Its name sounds less like poetry and more like paperwork, but its meaning is no less extraordinary. To be the third is to confirm a pattern, to shift the conversation from if to when. Once might be chance, twice might be coincidence, but 3 means inevitability. Pause with that thought for a moment. For thousands of years, humans looked at the night sky and saw permanence. The stars seemed fixed, the heavens eternal. Comets themselves were rare enough to inspire terror, and interstellar visitors? The very idea felt impossible. Our solar system seemed an island, lonely, self-contained. But then, in less than a decade, we've watched 3 outsiders sweep across our skies. The message is simple, but profound. The universe is not still. It is in motion, Systems trade fragments. The borders between stars are porous. And isn't it strange how easily the extraordinary becomes ordinary? With each new discovery, the sense of shock softens. When ʻOumuamua appeared, headlines screamed of aliens. When Borisov came, the news was quieter, almost relieved. And now, with 3i Atlas, the announcement has been met with a strange, calm curiosity. We have begun, in the span of a single human lifetime, to adjust to the idea that the cosmos is not closed off but open, that fragments from other suns will pass through ours, not once in a generation, but perhaps often, maybe even constantly. To astronomers, 3i Atlas is cataloged, logged, another data point. To the rest of us, it is something more. It is the third stranger at the threshold. And when the third arrives, tradition says you invite them in. What does it mean to have three? It means we now see that interstellar travelers are not myth, but part of the universe's fabric. It means our models of planetary formation must expand, that our sense of cosmic neighborhood must stretch wider. It means that even in the vast quiet, paths cross, systems touch. The stories of different suns overlap in a dance too large for us to watch, but not too subtle to leave traces. Perhaps most of all, the third one reminds us that discovery is not done. The sky is not empty. Each dot we see may carry a story written in alien chemistry, in dust that once orbited another sun. Each one is a messenger, not from gods this time, but from physics, from chance, from the grand churn of galaxies. And yet, with each visitor, the question deepens. If ʻOumuamua was strange, if Borisov was familiar, what will 3i Atlas prove to be? Is it the bridge between the two? A comet in shape but uncanny in detail? Or will it hold something we do not yet have words for? To be the third is to stand at the edge of expectation. We know more now than we did in 2017, but we still don't know enough. And so, once again, we lean forward. We wonder. We wait. Imagine for a moment that you are standing outside on a quiet night. The stars are steady above, but somewhere among them, invisible to your eyes, a faint body from another system is tracing its brief arc across our solar system's stage. You can't see it, you can't touch it, but you know it is there. The third one, the reminder that we are not closed off. The whisper that says the universe is still arriving. There is something haunting about the word hyperbolic. In mathematics, it describes a curve that never loops back, never closes on itself. It stretches outward, forever open, forever escaping. And that is the path of 3i Atlas. Not circular, not elliptical, not bound. Hyperbolic? What does that mean? It means this visitor is not staying. It is passing through, brushing our sun's warmth only once before vanishing into the dark again. Unlike planets, which are tethered to the sun's gravity, and unlike comets from the Oort cloud, which swing in and out over millennia, this object will not return. Its journey is a single line, a crossing, a farewell written in orbital mechanics. Consider the speed, 61 kilometers per second. Try to imagine it. That's nearly 220,000 kilometers every hour. In the time it takes you to blink, 3i Atlas has moved farther than most cities stretch. In the time you breathe, it has crossed entire countries. By the time you finish this thought, it has slipped tens of thousands of kilometers farther from where it was. And yet, against the vast backdrop of space, it seems slow. Our sun pulls at it, tries to bend its path, but the object's momentum is too great. It is like a stone thrown across a pond, skimming past the surface of our system, but never sinking in. This is why astronomers say it is a one-time guest. It has no orbit to chart, no regular cycle to anticipate. When it goes forever. Our telescopes will catch it briefly, our instruments will measure what they can, and then it will recede, fading into distance, too faint for even our sharpest eyes to follow. There is a melancholy in that, isn't there? To meet something from another world, to glimpse it only once, and to know we will never see it again. It is like finding a message in a bottle that washes ashore, only to be swept back into the ocean tides, unreadable in full, its sender unknown. And yet, there is also something purposeful in its path, because to travel on a hyperbolic orbit is to arrive with intention. Not in the sense of agency, perhaps not, but in the sense of inevitability. It was launched by some distant system's gravity, set on this course millions of years ago, and every kilometer it has traveled since has been part of a journey it cannot turn back from. When it passes our sun, it is not simply leaving, it is continuing. Its road is endless. Think of the distances involved. To cross from one star to another is to move across gulfs so wide that human imagination buckles. Even traveling at 61 kilometers per second, it would take tens of thousands of years to reach the nearest star beyond our own. And yet, here it is, proof that such crossings do happen. That matter does not remain confined to its birthplace, that pieces of one world find their way into another's sky. Some scientists see this as evidence of cosmic exchange. Perhaps interstellar objects like 3I Atlas are common, drifting unnoticed across the galaxy. Perhaps they are the seeds of panspermia, carrying organics from one system to another, scattering the ingredients of life like pollen across a cosmic field. If so, then 3I Atlas is more than a rock. It is a courier, a thread in the fabric of life's potential, stretched across unimaginable distance. But others wonder if such a precise, fleeting visit suggests more. Could such a path be engineered? Could the very fact of its hyperbolic escape hint at design, at something sent deliberately to pass by without lingering, to observe without staying? A probe that never needs to slow down, never needs to return, only to pass by, to watch, to move on. We cannot say. What we can say is that this is a journey without return. And in that, it mirrors something deeply human. We too move forward in time, unable to loop back, unable to repeat. We too are travelers who pass through, who glimpse, who say farewell. Perhaps that is why we feel a kinship with this object. Not because we know what it is, but because we know what it means to move on. So, as you rest, imagine 3I Atlas racing through the black. Its path curved, but never closed. A hyperbola traced against eternity. It does not stop. It does not stay. It does not return. And maybe, in that endless motion, it teaches us something about our own brief crossing through the universe. When most people picture a comet, they imagine something simple, a frozen ball of dust and ice drifting through space until it nears the sun. Then, under the sun's heat, the comet comes alive, its surface hissing, releasing jets of vapor and gas, painting a tail across the darkness. It's a beautiful sight, but in essence, it feels ordinary. Predictable. A comet is a comet, but interstellar objects like 3I Atlas complicate that picture. They are not familiar members of our solar family. They are foreigners, carrying with them the fingerprints of other systems. Each fragment of ice, each molecule of dust, may have been born under a different star, in a cradle of conditions we can hardly imagine. And that means that even if they look like comets, they may be more than that. Scientists remind us how rare these visitors are. For all the billions of stars in our galaxy, and for all the comets each star system may fling outward, we have only ever seen 3 such travelers with certainty. That's it. 3, out of countless possibilities. Their rarity means each one is precious. Each one is a messenger, a sample of another world's chemistry delivered to us free of charge, if only we know how to read it. And what might such a sample carry? Perhaps nothing more than ice, carbon, silicates, the same materials we find in comets closer to home. If so, That would still be extraordinary, because to analyze that material is to hold in our instruments the story of another system's birth. We would be studying the remnants of planets that never formed or stars that flickered out long ago. 3I Atlas would be a time capsule, its icy shell, a memory of conditions we will never otherwise touch. But there's another possibility. These objects may carry not just chemistry, but complexity. Organic molecules, the raw ingredients of life, amino acids, hydrocarbons, the building blocks that, under the right circumstances, can stir into biology. If comets in our solar system are thought to have delivered such ingredients to early Earth, sparking the first flickers of life, then what might a comet from another star deliver? Could it carry molecules we have never seen before? Could it bring whispers of alien biochemistry, structures evolved in a different nursery of light and gravity? And then, of course, there is the most daring question. What if these visitors are not simply accidents of nature? What if they are not just ice, not just rock, but technology disguised as the ordinary? A possibility so far-fetched, it seems almost impolite to say aloud, and yet it lingers. Because if you were an advanced civilization, seeking to observe others without drawing attention, what better disguise than something everyone expects to see? A comet, silent, unremarkable, and above suspicion. This is not to say 3I Atlas is such a thing. Most scientists are careful, cautious, and rightfully so. But the wonder lies not in the answer, but in the asking. To look at a speck of light and to wonder, what if? That is what expands us. That is what keeps curiosity alive. So, what is 3I Atlas? A comet, yes, likely nothing more, but also possibly something more than ice, because even if all it holds is dust, carbon, and frozen water, that alone is remarkable. It is dust not from here, water not from here, carbon not from here. It is the not from here that makes it extraordinary. As you rest tonight, imagine the nucleus of 3I Atlas, no larger than a mountain, drifting cold and dark through the void, its surface etched with scars of collisions, its core holding secrets from a star you'll never see. Is that just ice? Or is it more? Sometimes the line between the two is thinner than we think. Once word of 3I Atlas spread, telescopes across the world and beyond turned to it, like a room of curious faces all swiveling toward a single guest. The Hubble Space Telescope, the Gemini Observatory, ground-based lenses in Hawaii, Chile, and Spain. Each took its turn. The object was faint, never a dazzling streak, never the kind of comet that ignites public skies. And yet, to the careful gaze of instruments, it shimmered with a peculiar presence. At its heart was a nucleus, not vast, not a planet, not even a moon, but a body perhaps between 300 meters and 5 kilometers across. Small, fragile by cosmic standards, and yet carrying the dignity of something ancient and foreign. Around it glowed a coma, that soft envelope of dust and gas that comets exhale when sunlight touches their frozen skin. Trails of material drifted behind it in a delicate tail, the signature scarf of a traveler brushing close to a star. It was, at first glance, everything a comet should be. And yet every telescope that fixed upon it seemed to capture more than just ice and dust. There was a weight to its presence, a sense that, no matter how small, it was unmistakably other. Think about that word for a moment. Other. Not dangerous, not even strange in appearance, but undeniably not from here. A comet born in another system, shaped by a star we will never know, carrying the dust of worlds we will never see. Its coma shimmered with particles forged in the heart of alien suns, cooled in alien nights, cast adrift across gulfs of darkness, until, by sheer luck, it wandered across ours. The images gathered by Hubble showed not just a blur, but motion. Not the kind of motion you and I would see, a streak across the sky, but subtle shifts across exposures. the slow arc of something on its way in and then, just as quickly, on its way out. The Gemini telescopes traced the faint hues of its spectrum, measuring the light absorbed and emitted by its gases. Each line in that spectrum was a clue: oxygen, carbon, water vapor, the signatures of chemistry. Perhaps nothing exotic. Perhaps everything exotic. For even familiar molecules, when carried across interstellar space, become extraordinary. Astronomers worked carefully, comparing data, ruling out artifacts, refining measurements. They debated its size, its brightness, its trajectory. But beyond the math and the graphs, there was a more human truth, something humbling about watching this faint blur and realizing that it had traveled for millions of years to be here, glowing faintly for our instruments. For most of the public, the news remained quiet. Few would see 3i Atlas with their own eyes. To ordinary stargazers, it was invisible, hidden in the dark, noticeable only to those who knew where to look. And maybe that made it more alluring. The stranger at the edge of the crowd, seen only by those who pay attention. What did the scientists see? A frozen traveler? Yes, but also a mirror. Because in studying it, they were not just looking outward. They were glimpsing a reflection of our own solar system's place in the galaxy. 3i Atlas reminded us that we are not isolated, that dust and rock from elsewhere can and do pass through, that we are part of a larger web, an exchange of matter that binds suns together like drifting tides. It is easy to dismiss a blur of light as ordinary, easy to call it just a comet. But sometimes, the ordinary is the mask of the profound. Sometimes, the faintest shimmer in the telescope's eye carries with it the entire story of a universe that refuses to stay still. So picture it now. A small, icy heart adrift in blackness, glowing faintly under the sun's touch. A stranger observed from a distance by lenses and mirrors. Its every move recorded, its every particle cataloged. We cannot reach it, cannot touch it. But we can see it. And sometimes, seeing is enough. Most comets keep their secrets until they are warmed. They travel for eons in frozen silence, only beginning to stir when the sun's heat is strong enough to rouse them. Usually this awakening happens closer in, around 2 astronomical units from the sun, a distance where ice begins to vaporize and comets start to wear their luminous cloaks of gas and dust. But 3i Atlas broke the script. Long before it should have exhaled, it did. At 3.5 AU, roughly the orbit of the asteroid belt far beyond Mars, astronomers detected a whisper of water. Not torrents, not the dramatic outgassing of a comet on fire, but a quiet release. Hydroxyl molecules, faint traces drifting from its surface, recorded by NASA's Swift Observatory. It was like hearing someone breathe in their sleep before they've stirred. A sigh too early, a signal that this object did not play by the usual rules. Why does that matter? Because in the language of comets, timing is everything. They are predictable creatures of chemistry, their surfaces coated in ice that sublimates only when warmed. For 3i Atlas to release water at such a distance meant one of 2 things. Either its composition is unusual, or something about its surface makes it more sensitive than expected. Some scientists suggested it might not be water at all, but carbon monoxide or carbon dioxide, molecules that vaporize more easily at lower temperatures. Others wondered if the ice on its surface was unusually exposed, not buried under layers of dust as it often is with comets closer to home. If so, it might explain why sunlight, even faint and distant, could coax a response. But to others, the anomaly was a crack in the narrative. Why so early? Why so faint? Could this mean the object carries chemistry we've never seen before? Could its birthplace in a star system unlike ours have carved it differently, shaped its ice with pressures, temperatures, or elements unfamiliar to us? And then, of course, the quieter, stranger question: could such timing be deliberate? Could a probe disguised as a comet reveal itself in just such a way? Subtle, unremarkable, but enough to catch the attention of those watching closely, to breathe before expected, to hint at design. No evidence proves such speculation. The data remains within the bounds of science. Yet imagination, once stirred, is hard to quiet. The sigh of water at 3.5 AU was not loud, but it was enough. Enough to tilt heads, enough to inspire questions, enough to remind us that when the universe whispers, it rarely does so by accident. Think about that for a moment. A particle, a molecule, released into the void, traveling across millions of kilometers only to strike a detector in orbit around Earth. A trace so faint, it would be invisible to any human sense, yet powerful enough to shift how we think about this visitor. In that sense, the whisper of 3I Atlas was not faint at all. It was thunderous. And isn't there something almost human in it? To breathe too soon, to act before expected, to break a pattern. We often recognize life not by its conformity, but by its irregularities, by its quirks, by the way it surprises us. Astronomers continued to measure, to model, to debate. Was it water? Was it CO? Was it simply dust? The answers are still unclear, but the questions themselves are precious, because they remind us that this visitor is not just a rock on autopilot. It is an individual, unique, a story unlike the ones we already know. As you drift into quiet tonight, imagine 3I Atlas turning slowly in the dark, releasing a soft exhale long before the sun should have stirred it. A breath too soon, carried across space like a secret. Not enough to wake the world, but enough to remind us that sometimes the universe inhales and exhales in rhythms we have not yet learned to count. Comets, no matter how ordinary they may appear, are storytellers. Their tails and comas are libraries of dust and gas, each molecule carrying memories of where it was born. In the case of 3I Atlas, the dust it sheds may be the most important clue we have. Not because it glitters, but because it whispers of a place beyond our imagination. Astronomers studying its faint emissions proposed possibilities: carbon monoxide, carbon dioxide, organic rich particles drifting from its surface. These are familiar to us. We have seen them in our own comets. And yet, familiarity is deceptive, because these molecules were not forged here. They were not shaped under our sun's light or by the planets we know. They are fragments of an alien environment, a chemistry that unfolded under a different star's watchful glow. Think of dust for a moment. It seems trivial. What we wipe from shelves, what gathers in corners. But in astronomy, dust is sacred. It is stardust. Literally, the remains of exploded stars, the ashes of ancient furnaces, where heavier elements were forged. Every speck carries within it the story of collapse, of birth, of fire long gone. And when dust drifts from an interstellar visitor like 3I Atlas, it tells us of a system we will never see with our own eyes. Where did it come from? Some evidence suggests it may hail from a thick disk environment, a region of space where stars orbit differently, where gravity sculpts paths that do not match the thin, flat spiral of our galactic plane. Objects from such regions are rare, moving in unusual inclinations, their journeys shaped by gravitational encounters we can scarcely reconstruct. If true, then 3I Atlas carries not just alien chemistry, but the fingerprint of a place where the rules of motion themselves feel different. Imagine dust born under twin suns, where daylight came in two directions at once. Or particles shaped in the orbit of a giant planet larger than Jupiter, then flung into the void when that planet shifted. Imagine organics formed in a nebula richer or stranger than the cloud that gave birth to our system. Each speck trailing behind 3I Atlas could be such a relic, ordinary in structure, extraordinary in origin. And there's another layer to this. Dust travels. Once released, these grains can drift across interstellar space for millions of years, crossing gulfs between stars, moving with the slow tides of galactic motion. In that way, dust is a messenger too. It can seed other systems, deliver ingredients, even alter the chemistry of worlds far away. Some scientists believe that such grains, cast off by comets, may be one of the ways life spreads, or at least the way its ingredients do. If Earth received its first organic sparks from comets, then perhaps 3I Atlas carries sparks from somewhere else entirely. To most, dust seems insignificant, but here it becomes a cosmic signature, a postcard from an unknown sender. To catch it, to study it, is to glimpse the handwriting of a star system that may have died before humanity even existed. And still, the questions linger. What if the dust doesn't match what we expect? What if it carries structures we cannot explain? Complex molecules too delicate to survive without intent? Or more provocatively, what if it carries not the randomness of chemistry, but the patterns of design? Signals coded in dust, scattered deliberately, waiting to be read by anyone advanced enough to notice. Such speculation is easy to dismiss, of course. The sensible answer is that 3I Atlas is dust and ice, nothing more. But nothing more is itself astonishing. Because dust from a different sky is not trivial. It is contact, not with aliens perhaps, but with alien history. With the remnants of stars and systems that once burned in places our telescopes may never reach. As you close your eyes tonight, imagine that dust, tiny grains, smaller than the width of a hair, drifting out from 3I Atlas, sparkling faintly in reflected sunlight. Picture them for what they are, fragments of elsewhere drifting gently through our space for the briefest of moments, before vanishing again into the dark. Dust that is older than our mountains, dust that belongs to a sky we have never seen. Dust that reminds us we are not the only story the cosmos is telling. When news of an interstellar visitor reaches the public, the first question is almost always the same. Is it coming for us? We imagine collision, catastrophe, impact. Perhaps it's an instinct written deep in our bones, a memory of the great asteroid that ended the age of dinosaurs, or of the countless smaller impacts that have scarred Earth's surface. When the sky delivers something from beyond, fear is never far behind. But in this case, you can breathe easy. 3I Atlas will not strike us. Its path has been measured with exquisite care, charted through countless observations, its orbit refined until the numbers are precise. At its nearest, it will come no closer than 1.8 astronomical units. That's about 270 million kilometers, nearly twice the distance between Earth and the Sun. In cosmic terms, it may seem close. In human terms, it is a gulf. Instead, its closest approach will be to the Sun itself. In October 25, it will sweep through perihelion, its nearest point to our star. There, it will brush the warmth that awakens its coma, flare briefly in brightness, and then continue outward, accelerating away, back into the darkness. By then, it will have passed us by without ever coming within danger. A guest, not a threat. And yet, even from this distance, its presence carries weight. To know that something from another system has entered ours is enough to stir unease, even when it poses no harm. It is as though a stranger walked briefly through your home, not into your room, not close enough to touch you, but through the hallway outside, close enough that you heard their footsteps. You are safe, but you are aware. Astronomers reassure us with numbers. They point out that objects on hyperbolic orbits are travelers, not hunters. They pass through quickly, on courses dictated by physics alone. There is no intention in their paths, no malice in their motion. And still, for some, the thought lingers. What if? What if a rock the size of a mountain moving at 61 kilometers per second had been on a collision course with Earth? The energy released would be unthinkable, far greater than the most powerful nuclear arsenals combined. A blow not just to cities or nations, but to civilization itself, perhaps even to the biosphere. Such thoughts are difficult to silence. But here's the truth. 3I Atlas does not come for us. Its orbit is clear. It will not brush our atmosphere. It will not trouble our oceans. It will not even come close enough to be seen by the naked eye. If you were to step outside during its passage, you would not know it was there. Only the instruments of astronomers will mark its brief presence. And maybe that is for the best. Because what it carries is not danger, but story. A story written in its dust, in its chemistry, in its improbable arrival. A story we can study without fear, wonder at without dread. Too often, comets in history have been symbols of doom, omens of war, famine, the deaths of kings. But 3E's Atlas is not that. It is a reminder that not all visitors bring harm. Some bring only questions and the opportunity to glimpse what lies beyond our sun's small domain. There is a kind of humility in that realization. We are not the center of its path. We are not the reason it travels. It is not coming for us, and it will not wait for us. It moves according to a script written millions of years ago, by forces indifferent to our existence. And yet, for a brief moment, our lives and its path intersect, not in collision, but in awareness. So rest tonight without fear. The comet will not touch us. It will kiss the sun. It will drift away, and it will vanish again into the deep. And perhaps that is how it should be. For sometimes the most profound encounters are those that never come too close, the ones that remind us of our smallness, our safety, and our place in a universe filled with travelers who pass without harm. When we look at a comet, we are not just seeing ice and dust, we are seeing memory. Not the kind of memory you or I keep, but a cosmic memory written in molecules and minerals. Each fragment of frozen gas, each grain of dust, carries with it the conditions of its birth. In that way, comets are not merely objects, they are time capsules. For 3I Atlas, this is doubly true. It is not just a comet from our solar system's outskirts, not a leftover from the Oort cloud. It comes from elsewhere, from a place so distant that even our most powerful telescopes may never find the star that birthed it. That makes it a messenger from another world, one carrying a story older than our mountains, older than Earth itself. Think about what it means to hold a fragment of another system in our instruments. A speck of carbon, a trace of water, a glint of dust that once circled another sun, now captured in our spectrographs. It is like finding a fossil on a beach that drifted from a continent you have never seen, evidence of a history that does not belong to you, but which you can still read. Scientists know this. They treat such visitors with reverence. When ʻOumuamua appeared in 2017, it was unlike anything they had ever seen. When Borisov arrived in 2019, it offered a more familiar tale, a comet that behaved like comets we know, but still, its chemistry told of a place far away. And now 3 Atlas continues the story, giving us another page in the book of interstellar wanderers. What might its frozen stories reveal? Perhaps the balance of water and carbon dioxide within it, the fingerprints of its parent star's radiation, perhaps the ratio of isotopes, those subtle differences in atoms that tell us how hot or cold its birthplace was, how dense the nebula, how fast the star formed. Each measurement is a clue, a sentence in the biography of a world we will never see. And yet, there is also a poetic truth here. We are lucky. Lucky to have noticed. Lucky to have the instruments to catch even a glimpse. For the vast majority of such objects slip through our solar system unnoticed. The night sky is wide, the universe patient, and most travelers come and go without ever meeting our gaze. To have seen 3 in less than a decade is like finding 3 messages in bottles washed ashore in quick succession after centuries of empty tides. But stories can be misread. We must be cautious, careful not to project our hopes or fears onto them too quickly. A frozen story is not a prophecy. It does not speak of our future. It speaks of its own past. and it is up to us to interpret with humility. Still, wonder lingers. Because if this object carries organics, then it carries the ingredients of life from somewhere beyond our star. If it carries only ice, then it still carries water older than our oceans. If it carries nothing but rock, then even that rock is extraordinary, because it was not born here. Whatever its composition, it is never just anything. It is always more. So tonight, as you close your eyes, imagine 3i Atlas for what it truly is. A frozen story drifting through our solar system. A relic of another place, another time, another sun. It will not stay. It will not return. But for this brief moment, we are its readers. We are the ones privileged to glimpse the tale it carries, even if only in fragments. And when it vanishes, the story will not vanish with it. We will have recorded it. We will have read what lines we could, and we will remember that, for a fleeting season in 25, the universe handed us a book from another library, written in ice and light, and let us turn its pages before closing it forever. In astronomy, coincidences are tricky things. Space is vast, distances unimaginable, motions governed by strict laws of physics. To find order within that chaos often feels miraculous. And yet, with 3i Atlas, astronomers noticed something that made them pause. Its orbit, the exact path it traces through our solar system, appears almost too aligned. Let's step back. Our solar system is not random chaos. Planets, comets, and asteroids largely follow a shared dance floor, a flat disk called the ecliptic plane. This is the stage upon which Earth orbits, upon which Mars, Jupiter, and the rest sweep their paths. It's not perfect. There are tilts, inclinations, wobbling deviations, but still, the majority of motion happens here, as though gravity once pressed the system flat like clay. Now picture this. An interstellar object born far beyond, traveling for millions of years. Its path sculpted by unknown stars, unknown planets, unknown forces. What are the chances that, when it finally arrives in our solar system, it slides neatly into this ecliptic plane, threading itself through our cosmic dance floor as though it belonged here all along? The odds, according to some calculations, are vanishingly small, about 0.005%, a fraction of a fraction, as if you tossed a coin into the air and it landed on its edge, perfectly balanced. Once, you might call it chance. Twice, you might still shrug. But 3 times, that begins to whisper of pattern. ʻOumuamua in 2017 showed strange behavior, accelerating without a visible tail. Borisov in 2019 was a more typical comet, but still, its arrival through our solar system felt unlikely. And now 3i Atlas appears, gliding through the ecliptic as if deliberately choosing the stage where all our planets gather. Coincidence? Of course, it could be. Most likely, it is. But when the improbable happens repeatedly, even scientists allow themselves a moment of wonder. Could this alignment mean nothing? Certainly. The galaxy is full of billions of stars and countless objects drifting between them. By sheer statistics, some will happen to cross our paths in ways that look uncanny. Human minds are pattern-making machines, quick to see intention where there may be only accident. Skeptics remind us of this constantly. We are wired to read significance into randomness, and yet, the thought lingers. What if the alignment is not chance? What if passing directly through the ecliptic plane is not accident, but choice? If you wanted to observe a solar system without revealing yourself, wouldn't you aim for the region where the most activity happens? Wouldn't you drift where the planets circle, where life is most likely to emerge, where civilizations, if they exist, would notice you? That is the daring speculation some entertain. Not proof, not claim, but question. Could 3i Atlas be more than a comet? Could it be a scout, camouflaged as ice and dust, navigating deliberately along a path that lets it observe us without intrusion? Astronomers are cautious here. They emphasize probability, not intent. They note that while unlikely, such alignments are not impossible. They remind us of the dangers of over-interpretation. And yet, curiosity remains. The universe does not always conform to our expectations. And sometimes the most extraordinary truths begin as whispers of improbability. Think about how you feel when a stranger appears in a familiar place, a traveler on your street, a visitor in your town. You wonder why they came here, of all places. You wonder if there is meaning in their presence. That is what 3i Atlas stirs in us. Not fear, not certainty, but wonder at the possibility that chance is not the whole story. So tonight, imagine the object's path as a thread of light across a dark tapestry, slipping neatly into the plane where our planets turn. Imagine that alignment, improbable and uncanny, like a cosmic arrow drawn straight through the heart of our solar system. Perhaps it is only chance. Perhaps it is more. Either way, it is too aligned to ignore. The universe has its own sense of timing, and sometimes it feels almost theatrical. For months, astronomers had been charting the path of 3i Atlas, watching it approach, measuring its trajectory with growing precision. The world of science was preparing, eager to see this interstellar visitor at its brightest. And then, just as anticipation reached its peak, nature pulled the curtain. In October 2025, at the very moment when 3i Atlas will come closest to the sun, its perihelion, it will slip behind that blazing star from our perspective here on Earth. For weeks, it will be invisible to us, drowned in sunlight, hidden by glare. As though at the precise moment we wished to study it most, it chose instead to vanish. Astronomers call this a conjunction, when an object aligns so closely with the sun in our sky that it cannot be seen. Conjunctions happen often with planets, asteroids, even comets. But here, with an interstellar visitor we may never see again, the timing feels almost mischievous. A vanishing act performed at the peak of its passage. Why does this matter? Because perihelion is the moment when a comet reveals the most. The sun's heat ignites its frozen surface, releasing jets of gas and dust, forming tails that glow brilliantly. For scientists, this is the best time to measure composition, to see what elements emerge, to decode the chemistry of another world. And yet, for 3i Atlas, this moment will be lost to us, swallowed in the sun's radiance. Of course, logic explains it. Orbits are predictable. The mathematics of celestial mechanics tell us exactly why this conjunction occurs. There is no intention, no choice in the object's path. It simply happens to cross the sun's glare when we most wanted clarity. But our minds are not always satisfied with logic alone. To us, it feels deliberate. It feels as though the visitor is avoiding our gaze, slipping into hiding, revealing itself only in fragments before disappearing again. Some speculate, playfully but not without curiosity, that this could be the point. If 3i Atlas were a probe, what better way to minimize attention than to pass closest to the sun, masking itself in the brightest light in the sky, hidden not by stealth, but by brilliance, camouflaged by radiance? It would not need to maneuver, not need to cloak itself with advanced technology. It would only need to follow a path that nature itself provides, one that renders it invisible at the moment of greatest scrutiny. Others dismiss this as human imagination running ahead of itself. A comet, they remind us, is only a comet. The sun blinds us often. The timing is curious, yes, but not suspicious. Still, even skeptics admit it is frustrating. To have a visitor from beyond the stars pass so close, only to vanish at its most revealing point, is a reminder of the limits of our vantage. We cannot move Earth out of the way. We cannot silence the sun's glare. We can only wait, patient, for the object to reemerge on the other side. And yet, there is poetry in the disappearance. The vanishing act is part of its story. Like a character in a play who steps into shadow just before their motives are revealed, Three-Eye Atlas leaves us guessing. We will never see everything. We will never know the whole truth. But perhaps that is what makes the encounter meaningful. Think of it as a gesture. The universe saying, you cannot have it all. You can glimpse, you can measure, you can wonder. But some mysteries will slip away, hidden behind the light, beyond reach. So, as you imagine Three-Eye Atlas on its October crossing, picture it as a small, icy traveler, shining faintly, then swallowed in brilliance, erased from our sight at the very moment curiosity peaks. Not destroyed, not gone, only hidden, waiting on the far side of light. And when it emerges again, fainter now, already on its way out, we will have only fragments left to study. The full revelation will remain behind the curtain. The vanishing act complete. There is a theory in astrophysics and philosophy that chills the imagination. It is called the dark forest hypothesis, and it begins with a simple assumption. The universe is vast, ancient, and likely filled with life. If that is true, then why have we not heard from anyone? Why the silence? The answer, the theory suggests, is not comforting. Imagine the universe as a great, silent forest at night. Each civilization is like a hunter moving carefully through the trees. They do not call out, do not light fires, do not announce themselves. Because in a forest filled with hunters, the one who makes noise may not survive. Silence is safety. Camouflage is survival. To reveal yourself is to risk being destroyed by someone stronger. Now bring that image back to Three-Eye Atlas. A silent traveler, gliding across the ecliptic, showing just enough to spark curiosity, then vanishing behind the sun at its closest pass. To some, it is coincidence. To others, it is camouflage. Could this comet not be what it appears? Could it be a watcher? A probe hidden in plain sight, obeying the logic of the dark forest? To observe, but never to reveal? The thought is unsettling, because in this framework, aliens would not arrive with banners of peace or declarations of war. They would not announce themselves with signals across the stars. Instead, they would drift silently, disguised as debris, as comets, as ordinary rocks. They would not want to be found, only to watch, to measure, to learn. And Three-Eye Atlas fits the metaphor too well. A third interstellar visitor, sliding neatly through the stage where our planets circle, too aligned to ignore, too well-timed to feel like chance, hiding behind the sun just when we wish to see it most. Each detail, when stacked, begins to look like camouflage. Of course, skepticism pushes back. There is no proof here, only imagination. The comet behaves like a comet, a nucleus, a coma, a tail, gas and dust, nothing more. But imagination does not need proof to wander. It only needs coincidence. And Three-Eye Atlas offers plenty of those. The dark forest hypothesis does not claim that all civilizations act this way, only that the smart ones must. The reckless may broadcast their presence, shout into the dark, beam radio messages toward the stars. But the careful, the survivors, stay hidden. They send probes disguised as natural debris. They do not speak unless they are certain it is safe. It is a sobering way to think of the cosmos, because if it is true, then silence is not emptiness. It is strategy. It means we may be surrounded by watchers, their presence folded into the background of what we think is natural. A comet here and an asteroid there, ordinary in appearance, extraordinary in intent. And yet the theory also holds a strange beauty. For if the universe is a dark forest, then every faint glimmer we catch is not absence, but presence. It means we are part of a greater story, one where silence is not void, but caution. One where encounters are rare not because we are alone, but because survival demands restraint. So what do we make of Three-Eye Atlas? Most likely, it is only what it appears, a fragment of ice and rock, a relic of another star system. But the dark forest whispers otherwise. It tells us to be cautious, to wonder if what looks ordinary might not be ordinary at all. As you rest tonight, picture the forest. Picture yourself walking through its trees, the silence pressing in on every side. You do not call out. You do not make a sound. And somewhere in the shadows, something else is moving, silent as well, watching, waiting, just like Three-Eye Atlas slipping through our sky, a traveler we can see but never truly know. Science thrives on curiosity, but curiosity can be dangerous. Ask too much of the unknown, and you risk ridicule. Push too far, and you're accused of leaving science behind for speculation. Few people know this tension more than Avi Loeb, the Harvard astrophysicist who, in recent years, has made a reputation as both a respected scholar and a provocateur. In 2017, when Oumuamua swept past Earth, most scientists accepted it as an unusual rock, a shard of something natural. But Loeb saw something else. Its odd acceleration, its elongated shape, its lack of a typical cometary tail, these to him were not signs of randomness but hints of design. He proposed, carefully but firmly, that Oumuamua might not be natural at all. Perhaps it was a fragment of alien technology, a light sail drifting between stars. The reaction was swift. Many of his peers dismissed the idea as fanciful. Some went further, calling it irresponsible. Science, they argued, demands caution. Extraordinary claims require extraordinary evidence, and Oumuamua's data was too thin to support such leaps. To speculate so boldly, they warned, risked feeding public misconceptions and cheapening serious astronomy. But Loeb was not deterred. For him, the question was worth the risk. Why should we assume every anomaly is natural? Why should we dismiss the possibility of design simply because it makes us uncomfortable? His stance was not a declaration of proof, but a dare to wonder, what if? Now, with Three-Eye Atlas, his provocation echoes again. Loeb himself has not declared it alien, but the shadow of his earlier question lingers over this new visitor. Each time an interstellar object enters our skies, the conversation revives. Is this another shard of cosmic debris? Or could it be something more? This is the gentle provocation of Avi Loeb. He does not claim certainty. He invites debate. He points out that the universe is vast, that intelligent life elsewhere is statistically probable, that civilizations far older than ours may have technology indistinguishable from nature. And if that is true, why wouldn't we at least consider the possibility when the evidence strays from expectation? His critics remain steadfast. They argue that anomalies are not proof of intent, that comets and asteroids often behave in ways we don't fully understand. They point to the dangers of sensationalism, of allowing imagination to outpace evidence. In their eyes, science must remain grounded, careful, disciplined. And yet Loeb's questions resonate with the public. Headlines bloom, alien technology, probe in disguise. Even if scientists frown, people lean in, because at the heart of his provocation is a truth we all feel but rarely admit. We want to know we are not alone. We long for the extraordinary. The beauty of Loeb's approach is that it widens the frame. By daring to ask, he reminds us that the universe is not just a catalog of rocks and gases, it is also a mystery, a frontier of possibilities we cannot yet measure. His gentle provocation is not an answer, but an invitation to keep our eyes open, to look closer, to resist the temptation of certainty when mystery still lingers. And perhaps that is the role of such voices in science, not to provide proof, but to keep wonder alive. Without them, skepticism can harden into dismissal. With them, imagination finds a foothold. Loeb is not saying Three-Eye Atlas is alien technology. He is saying, do not be afraid to ask. So as you think of 3i Atlas tonight, drifting silently past our sun, imagine both perspectives. The cautious astronomer measuring spectra, confident it is only a comet, and the provocateur whispering, "But what if?" Between those two voices lies the true spirit of science, not certainty, but curiosity. It doesn't take much for a story to ripple across the modern world. A faint detection in a telescope, a cautious press release, a scientist's quote taken out of context, and suddenly, it's everywhere. With 3i Atlas, the whispers began quietly, but they spread like wildfire. Headlines bloomed almost overnight. Alien tech, probe in disguise, third interstellar visitor sparks mystery. The framing was irresistible. The words interstellar and alien do not need proof to ignite the imagination. They only need proximity. And so, even as astronomers carefully explained the data in sober terms, the news cycle spun a different story. One painted in brighter, more speculative colors. Social media amplified it further. Twitter threads dissected orbital charts. Reddit forums speculated about propulsion systems hidden in icy shells. YouTube videos whispered about probes and scouts. For many, the details of spectroscopy and hydroxy detections were less compelling than the narrative. What if we were being visited? And beneath all of it, a quieter truth stirred. These headlines were not simply about comets. They were about longing, humanity's deep, unspoken desire not to be alone, to find meaning in the vast silence of the universe, to believe, even for a moment, that someone else might be out there watching. It is easy to mock such reactions. Scientists do sometimes. They roll their eyes at sensational headlines, lament how the media twists careful research into clickbait. But perhaps it is worth pausing before judgment, because what these whispers reveal is not ignorance, it is yearning, a shared hunger to belong to something greater. The story of 3i Atlas did not spread because people love comets. It spread because people love wonder. A rock of ice traveling through the solar system is remarkable, but a possible messenger that captures the heart. And even when skeptics rush to correct, the whispers persist. Because correction addresses the facts. Whispers speak to hope. Of course, fact-checkers tried to quiet the fire. Snopes articles appeared, explaining that scientists were not calling it alien, that there was no evidence of technology, that the data aligned with natural explanations. Newspapers updated their headlines, softening the speculation. But by then, the whispers had already taken root. They no longer belonged to scientists. They belonged to the public imagination. And maybe that is as it should be. Science lives in laboratories and observatories, but wonder lives in people's hearts. When those two realms touch, sparks fly. Sometimes the sparks illuminate, sometimes they confuse, but they always remind us that discovery is not just data, it is story. Think of the way you felt when you first heard of ʻOumuamua, or Borisov, or now 3i Atlas. Even without knowing the details, there was something thrilling in the idea that a piece of another star system was passing us by. That thrill is not a mistake. It is part of what drives science forward. Without it, telescopes would not be built. Without it, funding would not flow. Without it, curiosity would wither. So yes, the whispers across the news feed sometimes distort the truth. Yes, they can run ahead of the evidence, but they also serve a purpose. They keep the public looking upward, even if only for a moment. They remind us that the sky above us is not empty. It is alive with travelers, mysteries, and questions. And maybe, just maybe, those whispers are not entirely wrong. Because whether 3i Atlas is just a comet or something stranger, it is alien. It does not come from here. It is a messenger from elsewhere, bearing the chemistry and dust of another star. That, in itself, is extraordinary. So tonight, as you scroll past headlines, remember this. Behind the exaggerations, behind the debates, there is something true and beautiful. A fragment from another system has passed through our skies. And for a brief moment, the world whispered together, wondering what it might mean. When whispers grow too loud, when speculation fills the air, there comes a moment when scientists feel compelled to answer, not with wonder, but with reassurance. That moment arrived quickly with 3I Atlas. As headlines turned toward aliens and probes, astronomers across the world began to lift their voices in unison, not to amplify mystery, but to temper it. Their message was simple: it looks like a comet. From observatories in Hawaii to radio dishes in Spain, from university classrooms to the quiet desks of researchers poring over spectral data, the consensus was cautious but clear. 3I Atlas behaved like a comet. It released gas, it shed dust, it formed a coma and a tail. Its orbit, while interstellar, matched the dynamics expected of an object flung from another system. No maneuvers, no signals, no sudden changes that defied physics. To most scientists, this was extraordinary enough, but the public conversation had already tilted toward something else. And so, a chorus of caution rose. Astronomers took to interviews, podcasts, and papers to remind us of the beauty of the ordinary. To say gently, yes, it is alien in the sense of being from elsewhere, but alien does not mean alive, and alien does not mean technological. Sometimes, the universe's greatest gifts are icy, not intentional. This chorus was not dismissive. It was protective. Scientists understand how quickly stories can spiral, how easily one speculative phrase can become a global headline. They have seen it before, with Mars meteorites, with ʻOumuamua, with mysterious radio bursts. A single anomaly becomes magnified into proof of life, when in reality it is only proof of how much we do not yet know. For many, skepticism is not cynicism. It is care. Care for truth, care for clarity, care for the delicate boundary between curiosity and misinformation. Without caution, science risks losing trust. And so the voices rose, calm and steady. It looks like a comet, it behaves like a comet until evidence says otherwise. That is the story we must tell. And yet, even in their caution, you can hear the wonder, because comets are wondrous things. To capture a fragment of another star system in our instruments is no small feat. To glimpse its chemistry, to study its dust, is to hold in our hands a relic of a place we will never touch. That too is magic, magic grounded in data, but magic nonetheless. Think of how delicate this balance is. On one side, excitement, imagination, the hunger for extraordinary contact. On the other, discipline, patience, the humility of restraint. Science walks this line carefully. It cannot afford to lean too far toward fantasy, nor can it afford to strip away the awe that fuels its pursuit. The chorus of caution does not silence wonder, it shapes it, keeps it steady, ensures it does not drift too far from the anchor of evidence. And for the public, this chorus has its own kind of comfort. To know that astronomers are watching, that they are measuring, that they are confident in what they see. That brings reassurance. The unknown is thrilling, but it is also frightening. A voice saying, "It's a comet," is a hand on the shoulder, a reminder that the sky above is not plotting against us, but offering a gift we can understand. Still, the whispers do not vanish. They never do. For every careful scientist, there is a dreamer who asks, "But what if?" That is the tension of discovery, the dance between caution and curiosity. Both are necessary. Without the chorus of caution, we would drown in unfounded claims. Without the dreamers, we might never look up in the first place. So let us honor the voices of restraint, the ones who remind us that extraordinary does not always mean supernatural. Sometimes, extraordinary means exactly what it looks like: a comet, frozen and ancient, passing through our skies. And that is miracle enough. In the age of the internet, stories move faster than comets. A whisper on one website becomes a roar on another, amplified by algorithms that prize excitement over accuracy. When 3i Atlas began its slow approach, the news cycle swelled with speculation. Alien probe? Messenger from another star? Technology in disguise? The words spread like sparks in dry grass. And then came the fact-checkers. Organizations like Snopes, Science Feedback, and others stepped into the fray, their digital pens sharp and steady. Article after article appeared, written in calm tones, designed not to thrill, but to cool. No, they wrote, scientists are not calling 3i Atlas alien technology. No, there is no evidence of propulsion, signals, or design. Yes, the comet shows normal outgassing consistent with frozen volatiles. The goal was not to extinguish wonder, but to keep it from flaring into wildfire. In the eyes of fact-checkers, misinformation is like a comet's tail itself. Once it spreads, it is hard to contain, and it glows brighter the further it travels. Their task was to trace the rumor back to its nucleus, separate speculation from science, and leave the truth intact. But here's the paradox. Silence does not travel as quickly as whispers. A denial never spreads with the same velocity as a rumor. Headlines announcing alien tech reach millions. Corrections reach far fewer. People prefer mystery to mundanity, questions to caution. And so, even as Snopes and others underlined the facts, the dream continued drifting across comment sections, forums, and late-night conversations. This is not new. When ʻOumuamua streaked through in 2017, the same pattern unfolded. A bold hypothesis, a storm of headlines, then a steady march of corrections. But even years later, ask the average person about ʻOumuamua, and some will still recall it as the alien rock. Not because the evidence supported it, but because the idea was too delicious to forget. With 3i Atlas, the cycle repeats. Silence may be truthful, but it is not sticky. Mystery clings. Fact-checkers can slow it, can temper its flames, but they cannot erase the longing beneath. And maybe they shouldn't. Because beneath every rumor, there is something honest. The human hunger to believe that we are part of a larger story, that the universe notices us, that the dark is not empty. When fact-checkers write they are not erasing wonder, they are shaping it, guiding it back toward what can be known without killing what cannot. Still, the tension is real. Scientists sigh at headlines that distort their careful work. Fact-checkers sigh at the speed of misinformation. And the public sighs at the silence of certainty, which often feels less exciting than the thrill of possibility. Each side wants truth, but truth wears different faces depending on where you stand. So what is left after the corrections? Silence. Not the silence of emptiness, but the silence of patience. The kind of silence in which scientists keep measuring, keep recording, keep waiting for more data. The kind of silence that does not deny wonder, but refuses to leap ahead of it. Imagine that silence tonight. Picture astronomers at their desks, quietly analyzing spectra, calculating orbits, writing careful papers that will never make headlines. Picture fact-checkers tapping out articles that few will share, even though they are truer than the viral posts. And picture, too, the silence of the comet itself, gliding wordless through the void, saying nothing, neither confirming nor denying, simply existing. That is the lesson of Snopes and silence. Truth is not always loud. Sometimes it is steady, patient, waiting to be heard by those willing to listen beyond the noise. Not every debate takes place under the glare of headlines. Some unfold in the quieter corners. Academic conferences, podcasts, journal reviews, even private emails between colleagues who have known each other for years. With 3i Atlas, the same was true. While the internet shouted alien probe, the real scientific conversations were happening in tones far calmer yet no less passionate. Take Samantha Lawler, for example, an astronomer known for her sharp skepticism. When questions about alien technology rose, she was one of the first to sigh, publicly, patiently, almost wearily. To her, speculation about probes was a distraction. The real science, she insisted, was in the details. The detection of hydroxyl gas, the odd timing of sublimation, the orbit threading the ecliptic. These were mysteries worth untangling, mysteries that could deepen our understanding of planetary systems beyond our own. Aliens, that was noise. Chris Lintott, familiar to many as the voice of BBC's Sky at Night, echoed that sentiment. He, too, rolled his eyes at the breathless speculation. In interviews and comments, he described such leaps as nonsense, a fog that only clouded the real beauty of the comet. Why turn to science fiction when the science fact was already extraordinary? A fragment from another star gliding through our skies was wonder enough. And yet, not everyone in those quiet corners agreed. Some astronomers, younger or less established, confessed, sometimes only over drinks, sometimes on anonymous forums, that they liked the speculation. They knew it wasn't likely, knew the data didn't support it, but still, they felt the pull. Isn't that what we're here for? One asked in a panel discussion. Not just to measure, but to wonder. This tension has always existed in science. The skeptics guard the boundaries, ensuring the field is not swept away by wild claims. The dreamers push at the edges, asking questions others dismiss. Both roles are necessary. Without skeptics, science risks crumbling into fantasy. Without dreamers, it risks becoming sterile, a catalog of facts without the spark that gives them meaning. With 3i Atlas, those roles were on full display. In papers, the language remained cautious. We find no evidence for non-gravitational acceleration. Spectral data consistent with cometary activity. But in conversations, in whispers, the debate continued. Could there be something more? Could we be missing a signal hidden in the noise? Could coincidence, alignment, timing mean more than they appeared? These quiet debates matter. They rarely make headlines, but they shape how science moves forward. A skeptical comment might steer a graduate student away from reckless speculation. A daring question might inspire a new experiment or observation. Science is not a monolith. It is a community, always in conversation, always balancing caution with curiosity. And in the end, perhaps that is where the real story of 3i Atlas lies. Not in the viral posts or the splashy headlines, but in the quiet corners where scientists argue, doubt, laugh, and wonder together. In the emails that begin, "I know this sounds crazy, but..." In the seminars where someone raises a hand and says, "What if we're wrong?" In the late-night musings of people who have devoted their lives to listening to the sky. So while the world spins its theories of alien technology and secret probes, remember the quieter debates too. They may not be glamorous, but they are where truth takes shape. They are where doubt and wonder dance, where skepticism and imagination meet, where science grows, not in shouts, but in whispers. In the story of discovery, doubt often plays the role of villain. It slows excitement, interrupts dreams, and drags the soaring wings of speculation back down to the ground. But in truth, doubt is not the enemy of wonder. It is its companion. Without doubt, wonder floats away into fantasy. With it, wonder gains shape, direction, and endurance. And with 3i Atlas, doubt has proven just as essential as imagination. When the first whispers of alien technology surfaced, fueled by headlines and curiosity, it was easy to be swept away. An interstellar traveler, aligned neatly through the ecliptic, vanishing behind the sun at perihelion. It sounded like the beginning of a science fiction story. And perhaps it could have been. But science demands more. It demands that each spark of possibility be tested against data, that each flight of fancy be weighed down with measurement. That is where doubt enters. Astronomers raise questions. If it were a probe, where is the evidence of maneuvering? If it were artificial, why does it display jets of gas, a coma, a tail, all signatures of natural comets? If it were hiding, why follow a path so easily predictable by gravitational mechanics? Doubt pressed against the walls of speculation, testing them for cracks. And where cracks appeared, the story shifted. What remained was sturdier, not as dazzling perhaps, but more true. This is not new. Doubt has always shaped science. When Galileo first pointed his telescope at Jupiter's moons, doubt forced him to check and check again, to prove they were not optical illusions. When Darwin proposed evolution, doubt demanded evidence. Fossils, finches, records of slow change. When Einstein bent space and time with mathematics, doubt required decades of experiments before relativity became accepted fact. Doubt is the shadow that proves the light is real. With 3i Atlas, doubt reminds us not to leap too quickly into conclusions. It urges patience. It reminds us that most comets behave strangely in one way or another. Outgassing can look unusual. Orbits can align by chance. Brightening at unexpected distances from the sun may not be a sign of design, but of chemistry we do not yet fully understand. Doubt does not erase wonder. It channels it into questions we can actually answer. And here lies the paradox. Doubt and wonder are not opposites. They are partners. Doubt protects wonder from collapse, giving it a foundation. Without doubt, we chase shadows. Without wonder, we stop chasing altogether. Together, they guide us along a narrow bridge, suspended between ignorance and understanding. Think of it this way. If we declared too quickly that 3i Atlas was alien technology, we would be wrong, and disappointment would follow. If we dismissed it entirely, calling it just a comet without curiosity, we would lose the chance to learn what it carries. Doubt allows us to hold both possibilities in tension, open to discovery, but anchored to truth. Even the skeptics, those most vocal in their dismissal of alien speculation, are part of this balance. They may sound weary, even harsh, but their caution is what keeps the field steady. They are the guardrails that prevent science from tumbling into fantasy. And the dreamers, those who whisper, "What if?" are the spark that keeps the journey alive. Between them, science moves forward, not in straight lines, but in careful steps, illuminated by both restraint and curiosity. So why does doubt matter? Because it saves us from ourselves, from the easy seduction of stories that are too good to be true, from the disappointment of chasing illusions, from the arrogance of thinking we know more than we do. Doubt humbles us, keeps us honest, reminds us that the universe is not obliged to fit our hopes. And yet, doubt does not kill wonder, it deepens it. For even when doubt strips away the fantastical, what remains is still miraculous. A frozen traveler from another star, carrying the chemistry of a place we may never see. To measure it, to watch it pass, to know even a little of its story, that is wonder enough. So let us not fear doubt. Let us embrace it as the steady companion of curiosity. For in doubt, wonder becomes real. And in wonder, doubt finds purpose. Together, they allow us to gaze at 3i Atlas, not with blind belief, nor with blind denial, but with eyes wide open, ready to see whatever truth the universe offers. At the heart of the speculation, the debates, the whispers across news feeds, one fact stands quietly but firmly: 3i Atlas behaves like a comet. And in that simple truth lies both the reassurance of science and the subtle wonder that sometimes gets lost in the noise. Let's start with what we actually see. When sunlight reaches the object, it warms its icy surface. Frozen volatiles, water, carbon monoxide, perhaps carbon dioxide, sublimate, escaping into space as gas. These escaping molecules drag dust with them, creating a glowing envelope around the nucleus called the coma. From this coma, solar winds stretch out a tail, a luminous scarf unraveling behind the traveler as it races through the void. These are not the signatures of alien engines, not the marks of technology, but the natural physics of ice, rock, and heat. Astronomers measure these emissions, and they match models of cometary behavior. The brightness increases as it nears the sun. The tail responds to solar radiation pressure. Jets erupt unevenly, causing slight wobbles in its path. All of this is exactly what comets do. And yet, in a way, that is the miracle. Because to behave like a comet does not make 3I Atlas ordinary. It makes it extraordinary in another way. It is the first time in human history that we can study in detail the cometary activity of an interstellar visitor. ʻOumuamua never gave us that chance. It was too small, too faint, too fast. Borisov gave us a glimpse, but it sped through quickly, its chemistry difficult to pin down. But 3I Atlas is brighter, more cooperative. It lets us see. For astronomers, this is like finding a message in a bottle, one not from our own ocean, but from a sea across the stars. Each molecule released into its tail is a word in a language written long before Earth was born. The hydroxyl detected by Swift, that is water, confirming that this object carries the same life-giving compound that nourishes our world. Its presence at a greater distance from the sun than expected. That is a clue about its structure, about the chemistry of the system that birthed it. These are not disappointments, they are revelations. Still, the human mind craves drama. To say it behaves like a comet feels less thrilling than to say it might be alien. But perhaps this is where we must pause, because behaving like a comet when you are a fragment from another star is not mundane. It is astonishing. It means that across light years, across the chaos of interstellar space, the same physics holds. Ice still sublimates under sunlight. Dust still streams into tails. The laws of nature are not just ours. They are universal. This realization carries its own kind of wonder. If comets in another system behave like comets here, then perhaps planets elsewhere orbit suns in familiar ways. Perhaps chemistry builds in patterns we recognize. Perhaps life, too, follows pathways that rhyme across the cosmos. In this way, 3I Atlas is not only a comet, it is a bridge, connecting us to the universality of creation. Of course, skeptics stress this point because it matters. By grounding our awe in evidence, they remind us that truth can be just as beautiful as speculation. The alienness of 3I Atlas does not require it to be a probe. It is alien by nature, alien in origin, alien in chemistry, alien in the sheer improbability of its visit. It carries with it the fingerprint of a star we will never see, the story of a system we may never explore. Think of that. While we dream of interstellar travel, while we build telescopes and craft simulations, a fragment of another world has come to us. We did not chase it. It found us. And by behaving like a comet, it gives us something priceless. Data, consistency, truth. Not fantasy, not deception, but a clear window into the ordinary miracles of the universe. So yes, 3I Atlas behaves like a comet. But in behaving like a comet, it tells us something profound, that the rules we know here are not ours alone. They belong to the cosmos. They stretch across light years, across gulfs of space and time, binding us to systems we will never touch. And that, perhaps, is the greatest wonder of all. If 3I Atlas behaves like a comet, then why do we still wonder? Why do the whispers of technology persist, despite the data pointing toward ice and dust? It is because deep down we ask, what would it take to prove otherwise? What would be undeniable? That question is as important as the observations themselves, because it teaches us where the line between nature and design truly lies. So, let us imagine. What signs would tell us that this visitor is not simply a comet, but something more? The first would be maneuvering. Natural objects obey gravity. They fall along predictable arcs, their paths shaped by the mass of stars and planets. But if 3I Atlas were to turn, truly turn, in a way unexplainable by jets of sublimating gas, it would be a revelation. A deliberate course change, a deviation from celestial mechanics, would signal intent. Rocks do not steer themselves. The second sign would be radio signals, not the background hiss of space, not the chaotic bursts of natural phenomena, but structured transmissions, patterns, repetition, regular intervals that suggest a sender, not chance. The great radio telescopes, Arecibo once, now fast in China, the Allen Telescope Array, and SETI's network, are tuned to listen for precisely this. If 3i Atlas were more than ice, it might hum faintly in radio waves, like a lighthouse beam sweeping unseen across the stars. The third possibility is silence, where noise should exist. A paradox. Imagine if the comet drew near, but no gas escaped. No dust trailed, no tail formed. If it remained pristine, inert, impervious to the sun's heat, that too would suggest something strange. Because comets must outgas, their chemistry demands it. If one did not, if it behaved too perfectly, too stably, we might suspect artifice. A fourth sign would be composition beyond nature. Imagine detecting alloys where there should be ice, metals arranged in ways that defy cosmic chemistry, a spectrum showing not carbon, hydrogen, and oxygen, but titanium alloys, silicon lattices, engineered materials that could not arise by chance. If JWST or ground-based spectrographs ever glimpsed such fingerprints, the debate would end in an instant. And yet, none of these signs have appeared. 3i Atlas drifts as comets do. It brightens, it breathes water, it glows with dust. No turns, no signals, no silence, no metals. Just the voice of ice meeting sunlight. But still, it is worth asking the question, because the act of defining what would count as evidence teaches us how to search. It sharpens our instruments, clarifies our goals, forces us to imagine what alien technology might even look like. Without the what if, we would not know what to look for in the first place. Consider ʻOumuamua. It puzzled us because its acceleration could not be easily explained by observed outgassing. The data was incomplete, the telescope time limited, and by the time we asked the right questions, it was gone. That lingering uncertainty, the almost of discovery, is what fuels our attention on 3i Atlas. This time, we want to be ready. This time, we want to know what something else would look like before the chance passes. And maybe that is the greatest sign of all, not in the object, but in ourselves. The fact that we keep asking, keep measuring, keep watching, that is proof of our readiness. Proof that humanity is learning how to balance caution with curiosity, skepticism with imagination. Each comet we study, each anomaly we investigate brings us closer to being able to recognize the extraordinary, should it ever appear. So, what would prove 3i Atlas is something else? A turn, a signal, a silence, a spectrum of impossible metals. None have been seen. Perhaps none ever will. And yet, by daring to ask, we stretch our vision, we sharpen our science. We remind ourselves that even the ordinary is extraordinary when it drifts across the gulf of stars to greet us. Because here is the truth. Whether comet or craft, 3i Atlas already is a sign, not of alien intent, but of cosmic connection, a fragment from elsewhere, reminding us that our sky is not empty, that the universe is alive with travelers, and that wonder is always within reach. Space is not silent. It hums, it crackles, it whispers. Pulsars beat like cosmic drums. Black holes flare in X-rays. Stars sputter with radio noise. Even the background radiation of the Big Bang still echoes faintly, a reminder of creation itself. But within this orchestra of natural sound, astronomers search for something different, a pattern, a signal, a voice. When 3i Atlas appeared, slipping across the void, radio dishes turned their ears skyward, not in frenzy, not with expectation, but with patience. This has become almost ritual whenever something unusual passes by. ʻOumuamua was listened to, Borisov too, and now 3I Atlas. The logic is simple. If an object is not from here, why not check, just in case it carries more than dust? The search for extraterrestrial intelligence, SETI, is older than most people realize. Since the 1960s, antennas have been tuned to the stars, listening for patterns amid the noise. So far, nothing lasting has been heard. There was the famous "wow" signal in 1977, a strong 72-second burst from Sagittarius that has never repeated. There are the countless false alarms, microwave ovens, satellites, the hum of Earth's own technology. And yet, the listening continues. Because silence is not proof of absence. It is only proof that we have not heard yet. For 3I Atlas, SETI's instruments searched for regularity. A radio signal made by intelligence would likely stand out because of its order. Nature is chaotic. Life is structured. A repeating pulse at an exact interval or a narrowband signal at a frequency unlikely to occur naturally would be a giveaway. Astronomers scanned the comet, sweeping through frequencies, hoping for a whisper against the static. So far, nothing. Only the size of space, the usual cosmic noise. And perhaps that is exactly what we should expect. If the dark forest hypothesis is correct, as we considered earlier, no probe would broadcast loudly. Survival depends on silence. A disguised messenger would not shout. It would only watch. But still, we listen. Because listening is more than just science. It is philosophy. To put an ear to the sky is to confess hope. It is to admit we long for an answer, even if the answer never comes. Each time a comet passes and SETI turns its dishes, humanity says, softly but collectively, "We are here. Are you?" There is also humility in this quiet listening. We are small, fragile, still learning. The distances between stars are vast beyond imagination. If another civilization has passed this way before us, leaving fragments like 3I Atlas behind, we may not recognize their signatures immediately. Our technology may be too crude. Our perspective may be too narrow. The best we can do is listen, carefully, patiently, knowing that recognition may take more than one lifetime. Some scientists frame it differently. They argue that even the act of listening is a kind of experiment. If nothing is ever found, that itself is data. It tells us about the universe, about the rarity of signals, about the strategies of life in a cosmos where survival may demand silence. Negative results are not failures. They are part of the map, charting what the universe is not saying. And then there is the poetry of it. Imagine the great dishes at night, tilted toward the sky. Imagine the faint hiss pouring into their receivers, the data flowing into computers, the software searching for order. It is almost like holding a seashell to your ear and hearing the ocean. Except here, the ocean is the cosmos, and the ear is not a child's curiosity, but an entire civilization's longing. So far, 3I Atlas has been quiet, but perhaps the point is not whether it speaks. The point is that we were listening. The act itself matters, the turning of antennas, the sharpening of instruments, the refusal to let silence mean indifference. For in listening, we keep ourselves open to the possibility that one day, the void may answer back. And if it never does, then the quiet itself becomes meaningful. Because even silence, when attended to with care, can teach us. It reminds us of our place. It humbles us. It makes us realize how rare and precious life on Earth truly is. 3I Atlas will pass, its whispers carried only in dust and chemistry. But the listening will not stop. The next visitor, the next anomaly, the next faint dot drifting across the sky, we will turn our ears again, because that is what we do. We listen to the quiet, and in the quiet, we find both patience and hope. When 3I Atlas first appeared, astronomers could not help but remember the one that came before, the visitor that slipped into our solar system like a ghost and left us with more questions than answers. Its name was ʻOumuamua, a Hawaiian word meaning scout or messenger. It was the first interstellar object ever confirmed, discovered in October 2017 by the Pan-STARRS telescope in Hawaii. And even now, nearly a decade later, it haunts us. ʻOumuamua was unlike anything we had ever seen. At first, astronomers thought it was a comet, but no tail appeared. Its light curve, the way it brightened and dimmed as it rotated, suggested an elongated shape, perhaps cigar-like, perhaps pancake-flat, tumbling chaotically through space. No one could quite agree. What puzzled scientists most was its acceleration. As it drifted away from the sun, it sped up slightly, as if pushed by something invisible. With ordinary comets, this makes sense. Jets of gas escaping from melting ice can act like thrusters, nudging the comet's path. But in Oumuamua's case, no gas was detected, no tail, no coma, nothing visible to explain the push. It was as if the object had received a gentle shove from nowhere. This mystery opened the floodgates of speculation. Papers were written. Hypotheses bloomed. Some argued it was a fragment of a larger body, shaped thin enough that sunlight itself could push it, what we call radiation pressure. Others proposed exotic ices that sublimated invisibly. And then came Avi Loeb, the Harvard astronomer who suggested, boldly, that perhaps Oumuamua was not natural at all. Perhaps it was a fragment of alien technology, a light sail, a probe, a relic of another civilization. The world seized on this idea. Headlines blared, alien spacecraft, interviews, debates, even books followed. Most scientists disagreed, pointing to natural explanations that fit more comfortably within physics. But Loeb's question lingered, not because it was likely, but because it was daring. Because it touched the part of us that yearns for contact. And then, just as quickly as it arrived, Oumuamua was gone. Too small, too faint, too fast. By the time the world had turned its attention to it, it was already slipping beyond the reach of our telescopes. The data we collected was limited, full of uncertainties. In the end, Oumuamua left us with no proof. Only memory, only mystery. This is why 3i Atlas matters so much. Where Oumuamua was fleeting, 3i Atlas is slower, brighter, easier to watch. It offers a second chance, not at alien proof perhaps, but at clarity. We do not want to miss again what we missed in 2017. We do not want another interstellar visitor to pass by wrapped in unanswered questions. And yet, memory colors our vision. Every anomaly we see in 3i Atlas, its early outgassing, its curious path through the ecliptic, is filtered through the ghost of Oumuamua. We cannot help but wonder, is this the same story? A cousin from the same unknown source? Another messenger drifting through? Or is it different entirely? More ordinary, more cometary, less mysterious? The shadow of Oumuamua reminds us of how fragile discovery can be. One missed opportunity, one telescope pointed too late, and the truth slips away. It pushes us to act quickly now, to observe relentlessly, to test every theory before this visitor too is gone. But it also teaches us humility. Because sometimes the universe does not give us neat answers. Sometimes it only gives us questions, wrapped in fragments of ice and rock. Oumuamua was such a question. And perhaps 3IA Atlas will be an answer, not of aliens, but of chemistry, physics, and the universal laws that govern matter across the stars. Even if 3I Atlas behaves more like a comet, even if it leaves behind no mystery unsolved, Oumuamua will remain in our memory, a reminder of how close we came to touching the extraordinary. And perhaps that memory is what makes us ready now, ready to listen more carefully, ready to measure more precisely, ready to accept whatever truth this new visitor offers, whether wondrous or ordinary. Because sometimes memory itself is a teacher. Oumuamua taught us what it feels like to almost know. 3i Atlas may yet teach us what it feels like to finally understand. When we speak of watchers, we often imagine something alien, eyes in the dark, hidden observers scanning our world. But with 3i Atlas, the watchers are us. Humanity has never had better tools for peering into the cosmos. And as this icy traveler arcs through our skies, some of our most powerful instruments are already preparing to gaze upon it. The most anticipated of these is the James Webb Space Telescope, JWST. Its golden mirrors, unfolded like a cosmic flower at the far side of the moon, give us sensitivity unmatched in history. JWST does not simply take pictures, it dissects light. It can look at the faint glow of 3i Atlas and split it into its spectral fingerprints, telling us exactly what gases are present, what dust is escaping, what chemistry lingers in the nucleus. Carbon monoxide, methane, organics. Each leaves a trace, a whisper in the light, and JWST's instruments are finely tuned to hear them. Scheduled for December observations, JWST's role is crucial because comets are storytellers. They carry within them the raw ingredients of their home systems, frozen in place for billions of years. To study 3i Atlas is to hold a vial of alien chemistry, one that condensed under another star, shaped by conditions our Earth never knew. We may never reach that star, but through this comet, we can taste its recipe. But JWST is not alone. The Gemini Observatory in Hawaii, the Very Large Telescope, VLT, in Chile, and the Hubble Space Telescope all play their parts. Hubble's sharp eyes capture the coma and tail in exquisite detail, measuring brightness changes over time. Gemini, with its adaptive optics, can track subtle variations in color, hinting at the composition of dust. The VLT, with its enormous mirrors, dives deeper into the infrared, complementing JWST's reach. Together, these instruments form a network of watchers, each angle of observation another piece of the puzzle. Even radio telescopes join in. By studying hydroxyl emissions, the breakdown products of water, they measure how much ice is turning into vapor. This tells us how active the comet is, how quickly it is shedding its material, how volatile its nucleus truly is. Every wavelength matters, every observation adds depth, and all of it is coordinated across continents, a global collaboration of watching. There is a quiet intensity to this process. Imagine the control rooms, the teams of astronomers submitting proposals, securing precious hours of telescope time. They prepare software to process spectra, algorithms to filter noise from signal. They wait for clear skies, for alignment, for the comet to rise above the horizon. Every detail matters, because once 3i Atlas is gone, it will never return. This is a one-time chance. And yet, behind the technical rigor, there is anticipation, almost a reverence. Scientists do not often admit it, but watching something like 3i Atlas is not just work. It is awe. To see light from an object that formed around another star, drifting for millions of years before slipping into our reach, that is not ordinary. It is an encounter with the vastness of creation. The watchers await not because they expect to find aliens, but because they expect to find truth. And truth, in this case, is richer than speculation. If JWST detects complex organics, it will suggest that the chemistry of life is not unique to our system. If it finds unusual ratios of gases, it will reveal conditions unlike those that shaped Earth. If the dust holds unexpected minerals, it will expand our map of what planetary systems can produce. Every outcome, whether exotic or familiar, deepens our understanding of the cosmos. Still, there lingers the quiet hope, perhaps not spoken in papers but whispered in thoughts, that something stranger could appear. A spectrum no one can explain, a silence where outgassing should be, a peculiarity that forces us to ask again, what if? That is the dual nature of the watchers, skeptical, yet open, grounded, yet dreaming. As 3i Atlas glides closer to the sun, the eyes of our telescopes will follow. And when December comes, JWST will turn its golden face toward this traveler, holding its light for the first time. Whatever it reveals, we will carry forward not only data and graphs, but the memory of having watched together across the Earth. The watchers await, and in their waiting, they remind us that science is not just about answers. It is about patience, persistence, and the willingness to look carefully, even when the outcome is uncertain. That, too, is wonder. Whenever a new visitor from beyond the stars is announced, the same dream appears almost immediately. Could we send a spacecraft? Could we chase it, intercept it, learn from it up close? With 3i Atlas, that dream rose again, tugging at the imagination of both scientists and ordinary skywatchers. After all, to send a probe, to photograph its surface, to touch its dust, would be to hold a piece of another star in our hands. But then reality sets in. The truth is sobering. We can't reach it. Not now. Not with the technology we possess. By the time 3i Atlas was discovered, it was already inbound, already moving at incredible speed. Interstellar objects do not drift slowly, they streak, pulled by the gravity of the sun, then slingshotting outward again on hyperbolic paths. For 3i Atlas, the velocity is staggering, about 61 kilometers per second. That's more than 200,000 kilometers per hour. By comparison, the fastest spacecraft humanity has ever launched, the Parker Solar Probe, travels at about 190 kilometers per second at perihelion, but only after years of careful slingshots around planets and the sun. Designing a mission to intercept 3i Atlas would require notice years in advance. Launch windows, trajectory alignments, and propulsion systems all need long preparation. By the time telescopes in Chile spotted 3i Atlas in July 25, the chance to act was already gone. Even if we launched instantly, our rockets could not accelerate fast enough to catch it before it sped past and away into the dark. This is the same frustration we felt with ʻOumuamua in 2017. By the time we realized what it was already leaving. Scientists dreamed of sending a probe. A project known as Project Lyra was proposed, involving advanced propulsion concepts, but it remained only on paper. With Borisov in 2019, we could watch, but still, we could not reach. And now, with 3i Atlas, the pattern repeats. Visitors come, we look, but we cannot follow. To change this, we would need a new strategy. Some suggest building ready probes, spacecraft waiting in orbit or at Lagrange points, primed to launch at short notice toward any interstellar visitor. Others dream of advanced propulsion, solar sails that can ride sunlight, fusion drives, even concepts like antimatter engines. Projects like Breakthrough Starshot imagine that sending gram-sized probes at a fraction of light speed to the nearest stars. But these remain ideas, not realities. They are decades away, if not more. So we must accept that 3i Atlas will pass beyond our reach. We will study it from afar, through telescopes and radio dishes, but we will not touch it. It will slip away, carrying its secrets back into the void, beyond the reach of human hands. And yet, even in this limitation, there is meaning. Because what 3i Atlas teaches us is not only about its chemistry or its orbit, it is about our own readiness. It shows us the gap between our dreams and our tools. It reminds us how small and slow we are in the face of the cosmos. That recognition is not failure. It is motivation. It is a call to build better, faster, bolder machines. Imagine, decades from now, a future where humanity is ready, where telescopes detect a new interstellar object, and within days, a probe launches, racing on solar sails, catching up, snapping photographs, sampling dust. Imagine bringing back a fragment, holding it in a laboratory, analyzing matter born under another sun. That future is not impossible. It is only waiting for us to close the distance between imagination and engineering. For now, though, the truth is clear. We cannot reach 3i Atlas. It is a guest we can only watch from a distance, like a ship passing on the horizon. But sometimes watching is enough. Sometimes distance teaches us patience. And sometimes, knowing that we missed our chance becomes the very spark that drives us, not to miss again. The comet will leave, and we will remain. But in its passing, it may ignite something lasting. The determination to be ready for the next visitor. To greet it not just with eyes, but with hands. After all the speculation, the questions, the debates, we must confront the simplest possibility. What if 3A Atlas is just a comet? No hidden engines, no alien craft disguised as ice, no silent probe drifting in the dark forest, just frozen rock and dust, born around another star, following a path determined by gravity and sunlight. At first, that answer may feel disappointing. After all, part of us wanted a story of discovery that would shatter our solitude. A signal, a maneuver, a revelation that we are not alone. Compared to that, just a comet seems almost dull. But this is where perspective matters. Because to call 3I Atlas just a comet is to underestimate how miraculous even that is. Consider what a comet truly is: a time capsule, a frozen archive of the earliest moments of a planetary system. In our own solar system, comets hold the chemistry of the beginning: water, carbon compounds, the same ingredients that may have seeded Earth with the building blocks of life. To see a comet from another system is to glimpse the beginning of a world that is not ours. A comet is not ordinary. It is a messenger from creation itself. And the rarity of this cannot be overstated. In all of human history, we have only identified 3 interstellar visitors: ʻOumuamua, Borisov, and now 3I Atlas. Out of the billions of stars, out of the trillions of drifting fragments, only 3 have crossed our telescopes. That makes each one precious, no matter how ordinary it appears. To dismiss such a gift, because it is just a comet, would be like dismissing the first seashell ever carried from a distant shore. Even the details of 3I Atlas's behavior carry meaning. The early release of hydroxyl gas, the brightness changes, the trajectory through the ecliptic. These are clues not just about this one comet, but about the environment in which it formed. Perhaps it was born in the icy outskirts of a young star, tossed into interstellar space by the gravity of giant planets. Perhaps it wandered for millions of years, silent and frozen, until chance brought it into our path. To learn this story is to expand our sense of how planetary systems live and evolve. There is also humility in the answer. If 3I Atlas is a comet, then it reminds us that we are not the center of everything. The universe is not designed around our expectations of drama and revelation. Sometimes it gives us silence. Sometimes it gives us ice. And in that simplicity, it teaches us patience, reminding us that knowledge grows not from grand announcements, but from careful study of small, fleeting moments. And yet, just a comet does not mean unimportant. On the contrary, it makes the object more valuable, because in its ordinariness, it tells us something profound: that the building blocks of worlds exist everywhere, that the chemistry that shaped Earth and life is not confined to our system, but scattered across the galaxy. If our comets carry water, and theirs do too, then perhaps life is not unique. Perhaps the seeds of life are sown wherever comets roam. So yes, it may be just a comet, but that phrase conceals wonder. Imagine holding a fragment of ice from another sun. Imagine watching its dust scatter into our sky, glowing briefly before vanishing forever. Imagine knowing that what you see once belonged to a world no human will ever touch. That is not ordinary. It is extraordinary. And maybe in the end, this is the lesson of 3I Atlas: that we should not need aliens or technology to feel awe. That the universe in its natural beauty is already astonishing. That a comet, silent, drifting, fragile, is enough to stir the deepest questions of existence. So what if it is just a comet? Then we are still lucky. Lucky to have seen it. Lucky to have measured it. Lucky to be alive in the brief window of time when it passed. For most of history, humanity never knew such things existed, and for most of the future, we may not see another. Just a comet? No. A messenger, a fragment, a reminder, proof that we are part of a universe still alive with motion, still generous with wonder, still tossing messages in bottles across the stars. The question refuses to fade. Each time we describe 3I Atlas as a comet, a whisper lingers in the background. But what if it isn't? What if it's a probe? Not a natural fragment, but a creation, a machine, a scout placed deliberately, drifting quietly through the currents of space. To imagine this possibility is not to declare it true. It is to play with the thought, to test its weight, to see what it would mean. And so let us imagine. What if 3I Atlas is artificial? First, we must ask, what kind of probe could it be? The simplest answer is a passive observer, a device designed not to land or signal, but to pass by unnoticed, collecting data silently. After all, in a universe where survival may require caution, the safest probe is one that hides in plain sight. Camouflaged as a comet, it could slip through systems without drawing attention. Its outgassing could be engineered, its orbit planned to mimic natural paths, its disguise nearly perfect. Or perhaps it could be something older. Not active, not awake, but a relic. A derelict probe, sent millions of years ago, long after its makers had moved on or vanished. Its machinery may be dead, its power gone, its purpose forgotten. To us, it looks like ice, but beneath could lie structures corroded by time, unrecognizable to our eyes. In this version, 3I Atlas is not a spy. It is a fossil of technology, drifting endlessly, waiting to be mistaken for stone. If it were a probe, what might it want? Perhaps nothing. Perhaps its goal is simply to observe, to measure the faint signals of our planet, the chemistry of our atmosphere, the brightness of our cities against the dark. A note in a cosmic ledger. Earth, alive, curious, dreaming. Or maybe its purpose is broader, not about us at all. It could be one of countless probes, scattered across the galaxy like seeds, drifting for eons, recording without interference. And here is where the idea becomes most haunting. If it is a probe, then we may not be the intended audience. Perhaps its makers will never return to collect the data. Perhaps it transmits back across distances so vast that we will never hear. Perhaps its mission is not to contact, but simply to witness. And if so, then as it passes, it may be watching, not intervening, not revealing itself, just marking our presence. Skeptics will rightly argue that there is no evidence for any of this. No signals, no maneuvers, no alloys, no mystery that cannot be explained by cometary physics. But speculation is not about proof, it is about perspective. It allows us to imagine ourselves into a larger story, to ask what it would mean if one day the improbable turned true. And what would it mean? If 3I Atlas were a probe, it would mean we are not alone and never have been. It would mean someone else, somewhere, mastered interstellar travel long before us. It would mean that our sky, vast and empty as it seems, has already been touched by other hands. That realization would reshape everything, our science, our philosophy, our sense of place. But perhaps the deeper meaning is not whether 3I Atlas is truly a probe. It is that we are ready to imagine it as one. A century ago, we might not have had the language. Today, we have telescopes, theories, and dreams. We can entertain the thought without dismissing it as fantasy. We can let wonder and skepticism coexist. So, what if it's a probe? Then someone is watching, or listening, or remembering. Maybe we are not the main characters of the story, but simply one more entry in a cosmic archive. Maybe we are part of someone else's quiet survey, or maybe we are alone in noticing, our imagination filling the silence with possibility. Whether probe or comet, The lesson is the same. The universe is alive with motion, and we are part of it. If 3i Atlas is a machine, it humbles us. If it is not, it still humbles us. Either way, it leaves us gazing at the night sky, asking the question again and again, what if? The universe is vast. Billions of stars, countless planets, endless distances. It is easy to imagine it as welcoming, full of potential neighbors, perhaps waiting to meet us. But there is another possibility, darker and harder to face. What if some of those neighbors are not friendly? And what if 3i Atlas is not just a comet, not just a probe, but something else, something cautious, something hidden, something we should not hope to notice? This idea is often framed through the dark forest hypothesis. In a galaxy filled with civilizations, the safest strategy may be silence. To reveal oneself is to risk destruction. Every signal is a flare in the night, a call that could attract hunters. In such a universe, survival depends on concealment. Species do not broadcast. They hide. And if they explore, they do so quietly, disguised, careful never to draw attention. If that hypothesis holds, then 3i Atlas as a comet makes perfect sense. Not because it is truly ice and dust, but because that is how it appears. What better disguise than nature itself? What better camouflage than the ordinary? If you were sending a scout across hostile space, you would not give it flashing lights or visible engines. You would give it silence. You would give it ice. You would make it indistinguishable from the billions of other rocks that wander the stars. And what if such a scout were not friendly? Would we know? Probably not. If its makers wished to observe without being seen, they would not announce themselves. They would not beam signals. They would not maneuver in ways that betray intention. They would pass quietly, recording, vanishing. The very absence of evidence could be the point. This thought is unsettling because it shifts our perspective. We often imagine that if contact ever came, it would come with trumpets, clear signs, obvious signals, messages meant for us. But perhaps the truth is the opposite. Perhaps contact has already come countless times and we never noticed. Perhaps the galaxy is full of watchers, disguised as comets, drifting silently, keeping their distance. If that is the case, then friendliness, or the lack of it, is irrelevant. The encounter is asymmetrical. We cannot touch them. They, if they wish, could touch us. But here's the paradox. If such probes exist, their lack of hostility may itself be a kind of reassurance. 3i Atlas will pass us by. It will not slow, will not alter its path, will not approach our world. If it is a machine, then it has chosen to remain hidden. That suggests not aggression, but restraint. A dangerous neighbor does not need to disguise itself to destroy. A cometary camouflage implies patience, not violence. Still, the question lingers. What if it's not friendly? What if its purpose is not observation, but assessment? What if Earth is one of many worlds cataloged, not with the warmth of curiosity, but with the cold precision of strategy? The thought chills because it reduces us to a data point, a planet noted for its activity, its life, its vulnerability. And then the probe moves on, delivering its quiet report to an audience we may never know. Speculation of this kind walks a thin line. Too far, and it becomes paranoia. Too shallow, and it ignores possibilities worth considering. That is why scientists balance the discussion carefully. They emphasize data, cometary behavior, natural explanations, and they are right to do so. But in the quiet corners of thought, in the late hours when the mind drifts, the question remains. Not because it is likely, but because it forces us to face our fragility. So what if it's not friendly? Then we must remember something crucial. Friendliness or hostility does not change the fact that we are small. Our strength lies not in imagining power we do not have, but in preparing, in watching, in learning. 3i Atlas, whether comet or camouflaged machine, is a reminder of how vast the universe is compared to us. And in that humility, perhaps we find our best defense, not weapons, but wisdom. Because if there are unfriendly watchers out there, their silence may already be our protection. And if 3i Atlas is nothing but ice, then its silence is still a gift. Either way, the lesson is the same. In a dark forest, one survives by treading carefully, listening closely, and never forgetting that we are not alone. We often think of communication in human terms, words on a page, voices carried on air, signals transmitted by machines. But the universe may speak differently. Its messages may not come as letters or broadcasts. They may come as objects, silent, drifting, wrapped in ice and dust. So let us ask, what if 3i Atlas is not just a comet, not just a probe, but a message? Not a message in the sense of language, but in the sense of intent. A symbol, a gesture, a cosmic pebble tossed into the pond of space, its ripples reaching us not through translation, but through wonder. Consider the way we send messages ourselves. We have launched probes, Voyager, Pioneer, etched with plaques and golden records. These are not functional blueprints or detailed instructions. They are symbols, a map, a song, a whisper of who we are. They drift through the void, unlikely to be intercepted, but meaningful simply because we sent them. Perhaps 3i Atlas is such a thing. Not a machine of purpose, but a gesture of presence. If it is a message, then what does it say? Maybe nothing more than, we were here, a record of existence, proof that life arose somewhere else long ago and chose to leave behind a marker. For civilizations separated by millions of years and trillions of kilometers, perhaps this is the only way to speak, not in conversation, but in evidence, not dialogue, but testimony. Or perhaps the message is more subtle. Perhaps the message is in the act of disguise, to appear as a comet, to blend into the natural fabric of the cosmos, may itself be a statement, a lesson, that survival requires humility, that one endures not by shouting into the dark, but by whispering. If so, then 3i Atlas is not just an object, it is a parable, a story written in ice, teaching us how to exist in a universe we barely understand. Of course, skeptics will remind us, comets exist. They form naturally, they travel, they pass through. There is no need to invent intention where none exists. And they're right. The data does not demand a message, but the act of asking, what if, is itself meaningful because it reveals our longing, our openness, our willingness to see significance in the silent. We cannot help but interpret, because interpretation is what makes us human. And perhaps that is the deeper truth. Even if 3i Atlas is just a comet, it has already become a message, not from another civilization, but from the cosmos itself. A reminder that the universe is not empty, that it is filled with fragments of other places drifting into our reach. Each interstellar object is a note in a symphony too vast to hear in full, but enough to remind us we are not alone in the music. Think of the stories we will tell. Generations from now, people may not remember the technical details, the eccentricity of its orbit, the percentage of water vapor, the calculations of mass and brightness. But they will remember that in 2025, a visitor came from another star. They will remember that we looked, we wondered, we listened. That too is a message. It says something about us, that we are curious, that we are willing to stretch our minds beyond the ordinary, that we are ready to see meaning in the sky. If 3i Atlas is a message, then perhaps the message is not to them, whoever they might be, but to us, to remind us of our place, to call us into humility, to stir us into wonder. A message not sent but received in the act of looking. So what if it is a message? Then we must decide how to answer. With fear, with silence, or with curiosity? Perhaps our answer is not in rockets or radio, but in continuing to look upward. Perhaps our answer is in patience, in readiness, in science itself. Because the universe may not speak in words, but in whispers of light and motion. And to hear those whispers, to interpret them, to let them change us, that may be the most profound dialogue of all. When Three-Eye Atlas finally slips away, vanishing into the deep night from which it came, what will remain? Not the comet itself. It will be gone forever, beyond our reach, beyond our eyes. What lingers will not be ice or dust, but something more elusive: memory, wonder, and the questions it stirred within us. Already, Three-Eye Atlas has changed us. Not physically. Its distance will always keep us safe. Not chemically. It leaves no trail of matter for us to gather. But emotionally, philosophically, cosmically, it has left an imprint. It has reminded us that the universe is not static, that it does not belong to us alone, that fragments of other worlds drift into our sky, carrying silent stories written before Earth even formed. For scientists, the legacy is data. Measurements of hydroxyl emission, spectra of dust, orbital calculations. Each observation will enter the archives to be studied for decades. Papers will be written, models will be adjusted. The chemistry of another system will be folded into our understanding of how stars and planets form. Even if the conclusions are simple, it is a comet. Those conclusions still reshape the map of what is possible. For dreamers, the legacy is imagination. Three-Eye Atlas has reopened the doors first cracked by ʻOumuamua. It has invited us to wonder, what if? What if it's a probe, a message, a disguise? Even if those questions remain unanswered, they matter, because wonder is fuel. It powers science, it drives exploration. It keeps humanity reaching outward instead of curling inward. A comet that makes us dream of aliens is not just a comet. It is a catalyst. And for all of us, the legacy is perspective. Looking at Three-Eye Atlas reminds us how vast time is, how small we are, and how lucky we are to witness even a glimpse of the beyond. Think of it. This fragment formed around a star, perhaps billions of years ago, cast into space by gravitational tides, wandering endlessly through the void. For millions of years, it was unseen, untouched, unremarked. And now, for a brief flicker of time, it passed into our sight. Out of all the epochs of cosmic history, it came here while we were watching. That coincidence alone is extraordinary. It also leaves behind a challenge. Each interstellar visitor so far has slipped past too quickly for us to reach. We watch, but we cannot touch. That frustration is also a gift, because it pushes us forward. It tells us to build faster ships, stronger telescopes, quicker responses. It reminds us that curiosity must be paired with preparation. Perhaps Three-Eye Atlas will be the spark that accelerates new missions, spacecraft waiting in readiness, technologies capable of intercepting the next visitor. If so, then its legacy will not be just knowledge, but progress. But perhaps the greatest thing it leaves behind is not scientific at all. It is the reminder that the cosmos is alive. Not alive with organisms necessarily, but alive with motion, with exchanges, with gifts. Comets wander between stars, dust scatters across light years. The galaxy is not a set of isolated systems, but a web, connected by fragments like Three-Eye Atlas. We are not cut off. We are part of the same story. And that story, in the end, is about humility and hope. Humility because we see how small we are against the scale of the universe. Hope because even in our smallness, we are capable of noticing, of asking, of dreaming. A rock of ice passes by, and somehow it changes us. Somehow it stirs conversations about life, intelligence, danger, beauty, meaning. Somehow it pulls our thoughts from the everyday into the infinite. So what does Three-Eye Atlas leave behind? Not fear, not answers, but a whisper. A whisper that says, you are not alone, not because there are others, but because you are part of something larger, because the stars are still speaking, and you are learning to listen. When it fades into the dark, we will still look upward. We will still wonder. And when the next visitor comes, and there will be another someday, we will be ready. Ready not only with telescopes and instruments, but with the quiet courage to ask again, what if? That is its gift. That is what it leaves behind.